Hello, welcome to this Gespy build stuff video. In this video we're going to build something for the Atari ST. When the Atari ST came out in 1985, it came with a disk drive for 3.5 floppies of 720 kilobyte. That was a lot then, especially compared to the 130 kilobyte of floppy disk for the Atari 8-bit computers. Now of course there's not so much anymore. In this video we're going to see if we can use modern storage with the Atari ST. So, let's get started! Nowadays, solutions exist to replace floppy drives with USB stick or SD card drives. But I think replacing the built-in ST drive for modern electronics disturbs the retro look of an Atari ST computer. That's why I went looking for an external Atari floppy drive to modify it with a modern storage device. And I found one. So let's open this up and see if we can convert it. And here we have him. There's a lot of tape used. Bubble wrap. That is how I like to see that. This must be the floppy drive. And the power supply. That does not look like the original plug. It's probably already been replaced. And here he is, the Atari SF354 single-sided floppy drive. Now he still looks good. Not much discoloration. Only a bit dirty, but we can clean that up. But other than that, I can't complain. Let's go open it up. Four screws on the bottom. Okay, the drive is connected with a 40-pin Molex connector instead the usual 34-pin PC connector. By removing 4 screws, we can detach the drive. It's a pretty heavy drive. How do we get this out? Okay, no screws, it's just clamped. This we will be reusing. Yeah, I would like to open the drive as well. What I already thought, the belt is dissolved completely. There are little bits of belts everywhere. But we're going to replace the drive anyway. Let's start cleaning the casing. it has been revived. Well, it looks like new again. Here was the drive mounted, but we won't be reusing it. Instead, I bought this. Oh, some sweets first. This is the Geox drive. It's a variant of the famous Codec drive. With the Codec drive you can read disk images from a USB stick. You select the disk image with this large rotary button. I actually find this a rather ugly solution. This button and also the USB stick sticks out quite a bit. With the Geox drive they use a more modest rotary knob. They also use an SD card instead of USB stick. They stick out less, and I also found an SD card a better modern variant of a floppy than a USB stick. The Geox drive comes with a 3D printed front cover that fits exactly the Atari ST drive casings, both the wide and the narrow eject button versions. Well, let's see if it fits in the SF354 casing. The screw holes match, but doesn't fit very well. Maybe if I place the screws it will straighten out. Now see if the front comes out right. It fits, but not perfectly. Okay, I filed away some plastic partitions next to the screw holes of the casing. Now the Geox fits perfectly in the case. Let's see if the front also comes out better now. Yes, that's much better. It now fits perfectly. Before we continue with the drive, I'm going to test the power supply first. We don't want the drive to be damaged by a faulty power brick. This should be 12 volts. And that's right. Now we test the 5 volts. And that's also correct. Now we're going to connect the Geox drive to the drive board. But now that the 14-pin Molex connector is attached to it, and the Geox drive has the 34-pin floppy connector. Luckily I found this PC floppy cable. This has a 30-pin floppy connector on it. And it fits exactly. So I'm going to convert this cable for this drive. Checking the length of the cable. I split the other end into loose wires. The wires are alternately connected to the ground. So I'll separate the wires. And I provide these ends with some solder. Now I can connect them all together. And this is the end result. I put the pin header on the other side so I can test the connections. First I measure whether there is a connection with the other side of the cable. Then I measure whether all odd pins are in contact with each other. So, all connections are correct. Then I now attach a wire to it, which I can later connect to the drive board. Tape the soldered ends together with some insulating tape. Remove the old connection cable from the drive board. Then we remove the remaining solder. And clean everything with some alcohol. Now we can connect the new cable. After studying the service manual and looking at some pictures on the internet, I came up with the following connections. And that's how it finally turned out. And again, I plug a pin header in the connector to test the connections. It looks like they all are correct. And now the power connector. There is a connector on the board that does not fit in the Geox drive. But I still have this floppy drive adapter cable, which does have the right connector on it. So I remove it from the adapter cable. We strip the ends and apply some solder. We remove the old power cable. And clean the solder islands again. We solder the new cable to the drive board. Now that the drive is ready, we can test it on an Atari ST computer. The drive is connected to the computer with a cable with 14-pin DIN connectors. Only that cable was not included with my drive. At first I thought, I will make one myself. But it appears that those 40-pin DIN connectors are no longer available. And when you find them, they are even more expensive than I paid for the whole drive itself. So we're going to make something ourselves. I found out that a 1.5mm VD wire fits exactly in a connector hole. So I cut 28 little pieces of that wire. I then soldered it to the wires of this data cable. I slide a piece of shrink tubing around these solder joints. This way they cannot make a short circuit. A piece of shrink tubing also goes around the end of the cable. And now we have my alternative connection cable. Now we can test the drive on an Atari ST computer. The cable must be connected pin by pin. I write down which color is on which connection, so I can connect the other side the same way. There he goes. Turn on the drive first, and then the computer. So I'm curious. I downloaded a disk image of first word, see if it can read it. Yes, he does. Unbelievable. I actually didn't expect that. There were so many things that could go wrong that I almost assumed it wouldn't work all at once. Here we have the front of the drive. There we still have the opening of the drive LED. If you look at the Geox, we also see an opening hole for a LED at that location. I want to make a power LED in there. This connector I will solder to the LED. And here we have connected the LED and provided it with shrink tubing. But of course there must be a resistor in between that. On the board of the Geox drive I found a connection point for 5 volts. I'm going to solder an angled pin header to that, so I can connect the LED to it. That's done. Now test whether it works. And we have light. Fits exactly in the hole of the drive. place everything in the case. You connect the power so we can see the result. Well, that looks good. And now the LCD display of the drive. Where are we going to place it? There's an opening in the drive through which the connection cable of the LCD display fits. But where are we going to place it now? I don't really like putting it on the front. I think the top of the case is a nicer location. See, here I like it. Then the cable must go through one of these cooling openings. To do this, the cable must be cut first. I put a stripe on the first wire, so later I know how it was connected. I soldered an extra cable to it to make it a bit longer. To test whether the wires are in the right place, I connect it to the drive again. Power it up and we have a picture. Now we can reassemble the drive. I attach the display with a piece of double-sided tape. Well, that's strong enough. For a final test, turn on the power again. Yes, it's working. It turned out pretty nice, if I do so myself. With the rotary wheel I can select a different disk image.
And this was the end of this video. I'm happy with how the drive turned out. Also nice that it worked in one go. I still want to have a real connection cable as soon as possible, so if anybody knows where I can get a 14-pin DEN connector for a reasonable price, please let me know in the comments below. And while you're there, please hit the like button so you support this channel. And you can also click the subscribe button so you stay informed for future videos. But for now I say, see you at the next build stuff video. Bye!